Okay, I have two screens. One screen is showing me discussing. The other one is showing the whiteboard. Pakipin yung screen na kung saan nakaproject yung whiteboard. Okay, kasi ito yung gagamitin natin. Also, make sure na, what do you call this? Make sure na naka-landscape yung mga phone ninyo or nakapahiga. Because we're going to maximize all of the spaces available for our discussion. Okay. So let's start first with balancing chemical equations since there are some who are requesting me to discuss balancing. Now, before we start balancing, magbigay muna tayo ng example. So we have Na plus Cl to produce NaCl. Now, in this example, alamin natin kung alin ang reactants at kung alin ang product. Now, ang nagdi-divide sa mga chemical reaction, chemical equation ay ang arrow sign. On the left side of the arrow, or kung saan hindi nakapoint yung arrow, which is these two, these are our reactants. Reactants. Ibig sabihin, sila yung mag-undergo ng chemical reaction. They are the ones who will undergo series of changes na kung saan mapapalitan ang kanilang mga chemical properties because of the chemical reaction. Kung saan naman nakapoint yung arrow sign, ito yun. Ang tawag doon ay product. Pwedeng isa, pwedeng dalawa, or marami ang product natin. Ibig sabihin, these are the substances that have been formed after a chemical reaction has taken place. Yung arrow sign natin, siya ang nagdi-divide between the reactant and the product. So gumawa tayo ng line para i-emphasize yung division. Now, hindi lang yung dalawang yan ang part ng chemical reaction, ng chemical equation. Meron tayong tinatawag na subscript and coefficient. Both of them are numbers. I-multiply nila yung sarili nila sa number of elements. What's the difference between the two? Yung subscript, ito yung small number written sa tabi ng element, kagaya nung kay chlorine dito. This is a subscript. It means, pinapakita niya na dalawa ang elements ni chlorine dito. Okay? So, let us have another example, H2O. Yung 2 dito ay subscript. Kaninong subscript siya? Kay hydrogen or kay oxygen? Open mic?
Hydrogen.
Hydrogen po.
Hydrogen.
Okay,
Hydrogen.
So the 2 dito ay kay hydrogen lang. So pinapakita dito na ang bilang ng hydrogen ay 2, samantalang kay oxygen ilan?
Isa.
Okay, correct. Isa. So yun yung subscript. Another example. Phosphoric acid, H3PO4. Ilan ang hydrogen dito?
3 po.
3. Kay phosphorus?
Isa.
Walang nakalagay na subscript pero given na isa yung kanyang subscript. So isa yung kay phosphorus. Ilan ang kay oxygen?
4 po.
Apat.
Okay, correct. 4. What about this one? Aluminum carbonate. Ilan lang kay aluminum dito?
Dalawa.
po.
Okay, correct. 2. Si carbon dito?
3 po.
Tatlo po.
Paano siya naging 3?
Multiplied by 9 yung subscript sir sa labas.
Okay, correct. Distribute. Kasi dito, si carbon dito ay isa. Si oxygen ay 3. Yun nga lang kasi, they are enclosed in a parenthesis, tapos may 3 dito. Yung 3 na subscript dito, ibig sabihin yan, i-distribute yan sa lahat ng mga nasa loob ng parenthesis. So, 3 dito, and then 3 dito. So, therefore, 3 times 1 kay carbon, 3. 3 times 3 kay oxygen, 9. So, ganun ang subscript. I-multiply niya yung number niya sa may nasa left side niya. Kapag nasa loob naman ng parenthesis, yung mga substances, and then may subscript doon, yung subscript, i-multiply niya yung sarili niya sa lahat ng mga nakapaloob sa parenthesis. What about coefficient? When we say coefficient, these are the whole numbers that we put right before the substance. At yung whole number na yun ay imumultiply sa lahat ng mga elements na nasa chemical formula ng substance na yun. For example, naglagay ako ng 2 dito kay hydrogen. Itong 2 dito, it will be distributed to all of the substances. So therefore, kay hydrogen dito, pag naglagay tayo ng 2 as a coefficient, magiging
4.
okay, correct, 4. Si oxygen ay magiging
2.
2. Maglagay ako ng 5 dito kay phosphoric acid. Ilan ang magiging hydrogen?
15.
15. Phosphorus?
5.
5.
Okay, oxygen?
20.
20.
Okay, maglagay ako ng 3 dito kay aluminum carbonate. Ilan ang magiging aluminum?
6.
6.
6.
Ilan ang magiging carbon?
9.
9.
9. Kasi 3 times 1 is 3 times 3, 9. Ilan ang oxygen?
27.
7.
Correct. 27. So, those are the different parts of a chemical equation. Now, we have 3 rules in balancing chemical equation. Number 1, you can only change the coefficient. You can never change the subscript. Masyado maliwanag. Okay. So, dito kasi, magbigay tayo ng another example. H2 plus O2 to produce H2O. Bakit si hydrogen tapos si oxygen kailangang may 2?
Diatomic element.
Diatomic.
Correct. That is because hydrogen and oxygen are 2 of the 7 diatomic elements, meaning they exist as pairs in nature. So, in accordance to the law of the nature, kailangan din natin maglagay ng 2 dito sa hydrogen at sa oxygen. Next, dito sa hydrogen, remember yung arrow sign ang magdi-divide sa dalawa. Kung ilan yung bilang ng element sa left side, dapat yun din yung sa right side. Kay hydrogen dito, dalawa. Sa product, dalawa. So, it is balanced. Kay oxygen dito ay dalawa, dito iisa. So, maglalagay ako ng 2 dito para maging balance. That is not possible and that is not allowed in balancing chemical equation. Kasi kapag pinalitan mo yung subscript, magiging ibang element na magiging ibang substance na yan. Kung H2O, ininom mo, that is water, walang mangyayari sa'yo, normal lang. Samantalang kapag itong H2O2, this is hydrogen peroxide or agua oxygenada, kapag ininom mo to, mamaya patay ka na. Bubula-bulo na yung bibig mo. You can never change the subscript of a substance because you're going to change the property of the substance kapag pinalitan mo. Next, first rule, you can only change the coefficient, never the subscript. Pangalawa, in balancing chemical equation, the coefficient must be whole numbers. So for example dito, sa oxygen dito dalawa, dito isa, so maglagay ako ng 0.5. Now, hindi yan pwede according to the second rule of balancing chemical equation because you can only put in whole numbers. Ibig sabihin, mga counting numbers. So that means hindi pwede ang 0.5 or 1/2. Dapat counting numbers. Third rule, kapag nagbabalance ka ng chemical equation, dapat naka-smallest whole number ratio siya. Okay, gusto ko maglagay ng 20 dito kay hydrogen. Nung naglagay ako ng 20 kay hydrogen, ilan na ngayon ang hydrogen dito sa reactants?
40.
40.
Okay, 40. Ngayon naman, 40 na ang hydrogen, samantalang sa product dito, dalawa. So what number should I put before the water para maging 40 din yung hydrogen?
20.
20. Yun nga lang, nung naglagay na ako ng 20 dito, ilan na yung oxygen ngayon dito sa product?
20.
20.
Sa reactant, dadalawa. So what number should I put dito sa reactant para maging 20 din ang bilang niya?
10.
10.
10. Okay. Kapag titignan natin, balance na. Yun nga lang kasi, we have to abide to the third rule of balancing chemical equation. Now, pwede pa naman natin i-lowest term yung mga values dito. What number should we put here para maging para mas bumaba yung value niya. Anong number natin sila pwedeng i-divide?
10.
Okay, so we can divide all by 10. So 20 divided by 10 will be 2. 10 divided by 10 will be 1. 20 divided by 10 will be 2. So ilagay natin yung mga values na ito. So 2, dito naman 1, you could either put 1 here, pero kapag 1 din lamang, as much as possible, hindi na natin ginagalaw. Because it is already understood na 1 na yung kanyang coefficient. Maglagay ng 2. So pag niliitan natin yung values, balance pa rin siya. Okay? So those are the 3 rules in balancing chemical equation. Number 1, you can only change the coefficient. You can never change the subscript. Pangalawa, coefficient must be whole numbers. Pangatlo, the final balancing should be in the smallest whole number ratio possible. So sagutan natin yung kay NaCl sa taas. Now, there are many ways in which you can balance chemical equation. It is discussed in the video na nakalagay natin sa module 12. Meron tayong using trial and error method, using odd-even method, and then using algebraic expression. So kayong bahala kung ano yung nakasanayan ninyo, so long as tama yung mga balancing ninyo. Okay. For Na, dito sa reactant ay isa, sa product ay isa. Kay chlorine dito dalawa, samantalang sa product, iisa. So what number should we put here?
2.
2.
Nung naglagay ka ng 2 dito, balance sa si chlorine, pero si sodium dito naging dalawa. Sa reactant, ilan ang dapat ilagay dito?
2.
2.
Oh.
Okay, so it is balanced. Another example. Okay. Kay aluminum, ilan dito?
1,
1.
2,
2. So what number should we put here?
2.
2.
2. Ilan ang oxygen dito?
2,
Dalawa
2.
dito ay
3.
3,
tatlo. So, kapag sa kabilang banda ay yung isa ay odd number, isa ay even, it would be best kapag yung odd number ay gagawin mong even number. So what number should we put here para maging even number yung oxygen?
2.
2.
So 3 kasi siya, para maging even, the smallest number that we could multiply 3 is by 2 para maging
6, even.
6. Okay, para maging even, para maging 6. Ilan na ngayon ang oxygen dito? Dalawa. What number should we put here para maging 6?
3.
3.
3. Yung aluminum dito, dalawa. Tapos naglagay ka ng 2 na coefficient, kaya naging 4. Dito ay dalawa. So palitan mo yan, magiging 4.
4.
So that is how we balance chemical equation using trial and error method. Next. C8H18 plus O2 to produce carbon dioxide plus water. So this is an example of a combustion reaction. Okay, so how do we balance this? Open mic, please. Hello? Can you hear me? Okay,
Hello,
ilan ang carbon dito?
8 po.
Okay, what number should we put here para maging 8 din ang bilang ng carbon?
8.
4.
8.
4.
Next, si hydrogen ay 18 dito sa ating reactant. Sa product, dadalawa. What number should we put here para maging 18 din?
9.
9.
Next naman, yung oxygen. Dito ay dalawa. Dito sa product, remember na sa iisang side lang sila, kaya kailangan nating bilangin or pagsamahin yung bilang ng oxygen sa lahat ng substances sa product. Dito, 8 times 2, ilan ang oxygen dito sa carbon dioxide?
16.
16. Dito, ilan ang oxygen dito sa water?
9.
9.
So, 16 plus 9. So, ibig sabihin, 25 ang oxygen dito sa product. Sa reactant, dalawa. So, what number should we put here para maging 25?
Wala po. Uneven.
12.5, di ba? Yun nga lang kasi, may point siya. So, para mawala yung point, ano yung number na pwede nating i-multiply sa lahat para maging whole number siya?
2.
2. So, i-multiply natin ito sa 2. So, 2 times 1 is 2. 12.5 times 2 will become
25.
25. 8 times 2 will become
16.
16.
16. 9 times 2 will become
18.
18.
18. So, yan na yung kanyang smallest whole number ratio possible. So, it is now balanced. Another example, AL, ano kaya? OH3 plus CA sorry, mali. Plus AlCO3 plus H2O. Okay. What about this one? Let me check kung tama ang ating equation. Aluminum hydroxide, carbonic acid, aluminum carbonate water. Okay, correct. So, kayong bahala. Susundin ko lang kung ano yung ibibigay yung instructions sa akin sa pag-balance. First is, anong element muna?
Aluminum.
Okay, unahin natin si aluminum. Ilan ang aluminum sa ating reactant?
2 po. Ay, isa.
May hindi po maka-join. That is because we are at the limit. 100 lang po ang pwede mag-participate. So yung mga hindi maka-join, yung sa video na lang ang abangan nila. Okay? So dito, isang aluminum, dito dalawa. So we have to put 2 sa aluminum hydroxide. Next, what other element should we look? Yung oxygen kasi medyo mahirap kasi dito may oxygen dito sa aluminum hydroxide tapos sa carbonic acid. Yung hydrogen meron dito tapos meron din dito kaya medyo mahirap. Yung single lang muna, yung mag-isa niya lang.
Carbon.
Okay. Dito ang carbon ay
Isa.
dito ilan?
3.
Tatlo.
Okay, so we are going to put ilan dito?
3.
3. Okay. So balance lang ang aluminum, balance na din ang carbon. Let's look at the hydrogen. Ilan ang hydrogen dito sa lahat?
6.
6. Kasi 1 times 3 is 3 times 2, 6. Ilan ang hydrogen dito?
6.
6. Sa product naman, ilan ang hydrogen dito?
2.
2. Ilan ang kailangan niya coefficient ni water para maging pantay ang bilang ng hydrogen niya sa reactants?
6.
Okay. Kasi dito, 6 ang kay aluminum hydroxide, 6 din kay carbonic acid, kaya 12. So we put 6 dito para maging 12 din ang bilang ng hydrogen. Ilan naman ang oxygen dito?
3. 6.
Okay, 6. Kasi 3 times 1 is 3 times 2, 6. Dito naman, ilan naman dito? 9. So 9 plus 6, 15. 15 lahat sa reactants. Dito, ilan dito ang oxygen?
9.
9. Dito, ilan ang oxygen dito?
6.
6. So 9 plus 6, 15. Kaya parehong 15 na sa reactant at sa product. So that is how we balance chemical equation. Okay? Now let us have one example ng limiting an excess reagent. Then we can proceed to gas laws. So there's no need for you to take screenshots of our lesson. It will be posted in the Google Classroom and in YouTube. Kasi yung iba, mas mabilis mag-loading ang YouTube kaysa sa Google Classroom or Google Drive nila. Okay. So for example, let us have pH 3 plus oxygen to produce P2O5 plus H2O. Sorry. Mali. Mali yung aking example. Hindi, okay na yan. So, for example, we have 35 grams of pH3. So, for example, i-burn natin yung ating phosphorus trihydride or in other terms, phosphide. So, since binurn siya, it will react with oxygen. Ang tanong naman ngayon ay ilan ang mapoproduce na diphosphorus pentoxide at water? Ilan ang mapoproduce sa kanila in grams? Now, the first step in all of this is,
Multiply the given.
okay, pangalawa yon.
Balancing.
Yes, balance.
Balancing.
Sorry, I mean, ang pinakauna is to write down the chemical equation kasi dito sa example natin sa book, yung sinend ko din sa inyo, nakalagay na yung chemical equation. However, there will be instances na ang nakalagay ay word lang. Wala siyang equation na ibibigay. And then you have to get the equation from the question. So, number 1 is to write down the chemical equation. Ito nakalagay na. Pangalawa is to balance the chemical equation. How do we balance this one? Paano natin siya ibabalance?
Make oxygen even.
Okay. Medyo itabi muna natin si oxygen kasi may oxygen dito sa P2O5 tapos dito sa H2O. So kapag unahin mo siya, medyo mahirapan ka. Doon ka muna sa single na substances. Yung sa buong reactants or sa buong product ay mag-isa niya lang.
Phosphorus.
Okay, we can make use of phosphorus. So, how do we balance this one? Maglagay ng?
Add 2 to
Two.
Okay, 2 doon may phosphorus na reactant. Naglagay ka ng 2 dito. Ilan na ngayon ang hydrogen?
6.
6.
Kami ka lang sa product?
2.
2. What number?
3.
3.
So, naglagay tayo ng 3 dito. Sa products, 5 ang oxygen dito. Dito ay 3. So, ilan lahat? 8. Di ba? So, what number should we put here kay oxygen?
4.
Okay. 4. So, this is now balanced. Okay. Next step, identify the given. The given is 35 grams of phosphide. Ilan daw ang mapoproduce na P2O5 at H2O? So, since ito ay nasa grams, kailangan muna natin siya i-convert sa mole. Pwede natin siyang i-diretso na yung computation or isa-isahin. Pero mas maigi na yung isa-isahin para mas naintindihan. Let me get my calculator. So, also prepare your calculators. So, 35 grams of pH3. Now, how do we compute for the mole of this one? Remember our triangle? Mole dito, weight, molecular weight. Nawawala ang mole, so the formula is weight over
Molecular weight.
molecular weight. So, this is our weight. We have to divide this with the molecular weight. So, divided by, the molecular weight is, sa phosphorus, isa, times, it is 30.97, if I'm not mistaken. For hydrogen, it is 1 times 1.01. Okay. Sorry, tatlo pala siya. So, 30.97, 3.03. So, therefore, this will be equal to 34 grams per mole. Lahat ng unit na kinukuha natin sa periodic table, grams per mole ang unit. So, 34 grams per mole. Cancel grams, ang may iwan lang ay mole. So, 35 divided by 34, this will be equal, mole ang may iwan kaya dapat 4 decimal places. This will be 1.0294 mole. Okay? So, nakuha na natin ngayon yung mole. What's next is for us to determine the stoichiometric equivalence. So, kunin natin yung given, 1.0294 mole of pH3. Ang given natin ay sa pH3, ang hinahanap muna ay kay P2O5. So, using the coefficient, we can say that for every 2 mole of pH3, it is stoichiometrically equivalent to 1 mole of P2O5. Bakit 1 mole? Kasi walang nakalagay, kaya automatic or it is understood na 1. So, kailangan natin na nasa baba yung same unit ng given natin. So, 2 mole of pH3, 1 mole P2O5. Anong ilalagay natin sa baba?
2 pH3.
Okay, so 2 moles of pH3. Kasi para ma-cancel. And then 1 mole P2O5. Okay? So we can now cancel. This will be equal to 0.5147 mole of P2O5. Pero ang hinahanap ay grams. So pag nawawala yung weight using the triangle, it will be mole times
Molecular weight.
okay, molecular weight. For molecular weight, si phosphorus, dalawa times 30, dalawa times 30.97, 2 times 30.97, plus kay oxygen, 5, ang bilang ng kanyang atom, times 16. So our molecular weight is 141.94 grams per mole. So makakansal yung mole, may iwan yung grams. So this will be equal to 73.06 grams. So ito yung amount na mapoproduce na sa P2O5. What about oxygen? Dito yung P2O5. For oxygen naman, we are going to make use of the number of moles pa rin ng pH3. So 1.0294 mole. As I have said before, kapag nagko-compute tayo, it would be best if you're going to compute with me, hindi yung nanonood. Kasi mas maintindihan mo kapag nagko-compute ka rin. So 1.0294 mole ng pH3. Next, we get the stoichiometric equivalence. pH3 and then oxygen. Water. H2O. This is supposed to be H2O. So, pH3 and water. So, 2 moles of pH3 is stoichiometrically equivalent to 3 moles of water. Ang titignan natin dito ay yung kanilang coefficient. Now, since ang ating unit dito ay mole of pH3, dapat ang nasa baba din natin ay yung mole ng pH3. Based on the balancing, 2 mole of pH3 is stoichiometrically equivalent with 3 moles of water. So 1.0294, that is our given, divided by 2 times 3. This will be equal to 1.5441. 4 decimal places kasi mole ang ating value. Next, weight ang kinukuha uli natin ng water. For H2O, hydrogen, 2 ang bilang, times 1.01. I-add natin yon sa 1 times 16. So this will be 18.02 grams per mole. Cancel mole, ang may iwan lang ay grams. So, sorry, mali yung sagot ko. So what is our final answer? This will be equal to 27.82. Okay, 0.82 grams. So ito yung maproproduce na water. 27.82 grams. Okay. Another question here is sa letter D. If the reaction gives 64% yield, how many grams of pH3 should be used to produce an actual yield of 250 grams of P2O5? Kapag ang percent yield daw ay 64% at ang actual yield ay 250 grams of P2O5, ano ang kailangan nating theoretical yield? I will erase the top part of the board. So dito naman, pwede tayong gumamit ng triangle. So dito yung actual yield, dito yung theoretical yield, dito yung percent yield. Kapag ang nawawala ay yung percent yield, it is actual yield divided by theoretical yield. At since percent siya, times 100. Pag nawawala ang theoretical yield, it is actual yield divided by percent yield. Pero yung percent, kailangan mo munang i-divide sa 100 para maalis yung percent. Okay? So dito sa given natin, we have 64%. So ang given ay 64% yield at ang ating actual yield ay 250 grams. So what will be our formula? It is Ty is equal to Ay divided by Py. Pero ang Py, kailangan muna nating i-divide sa 100. Bakit kailangan nating i-divide sa 100? Kasi percent yield ang nakalagay dito. Percent siya. So we have to remove the percent. So this will be equal to 250 grams divided by 64% divided by 100. So 250 divided by 64. Our theoretical yield is 390.63 grams. So ganon. Kapag nawawala ang theoretical yield, it is actual yield divided by percent yield. Pero kailangan mo munang i-divide sa 100 yung percent yield para maalis yung percent. Pag nawawala ang percent yield, actual yield divided by theoretical yield. At since percent yield nga siya, kailangan makuha yung percent times 100. Pag nawawala ang actual yield, it is theoretical yield times percent yield. Okay, gets? Okay. Now we go to your gas laws. So far, may question kayo sa percent yield, sa limiting and excess? Do you have any questions so far?
None, sir.
Okay, none. Dito medyo kailangan natin ng madugo-dugong discussion dito dahil we are going to discuss 6 gas laws and each of them has different formula. Okay. Now, when we say gases, these are substances wherein, ano yung mga alam nating characteristics sa gases? Yung elementary tayo, sinasabi natin na ang gas, they take the shape of their container and they do not have definite shape and volume. Kung ano yung volume ng container, yun yung magiging volume din ng gas. Kung ano yung shape ng gas, yun din yung magiging volume ng yun din yung magiging shape ng kung ano yung shape ng container, yun din yung magiging shape ng gas. Kung ano yung volume ng container, yun din yung magiging volume ng gas. Bakit kaya? That is because, according to the kinetic molecular theory, ang mga gas particles, maliliit yung mga yan. And that these particles are constantly moving. Dahil sila ay constantly moving, they're always going against the walls of the container. So, binabangga nila yung walls ng container, maski yung mga particles ng gases mismo nagbabanggaan. So that means, since they are maximizing all of the spaces inside the container, yun yung nagiging volume din mismo ng gases. Bakit ang shape? Kasi ganun nga din, same rationale, kung bakit ganun din yung magiging shape ng gases sa kanyang container. So, those are 2 of the characteristics of gases. Next is compressibility. Madaling i-compress ang mga particles ng gases because they are very small. Maliban dyan, they do not take up much of the spaces according to their sizes. Another thing, what do you think are the other characteristics of gases? May mga factors ba na nakaka-affect sa properties ng gases?
Combustibility.
Okay, those are what do you call this? Chemical properties of gases. So, ang mga gases, depende sa kung anong uri ng gas sila, they can be combustible or not, they can be flammable or not. Kagaya ng oxygen, ang oxygen, it encourages combustion. Now, ano yung mga different factors na pwedeng maka-affect sa mga gases?
Temperature.
And temperature.
Temperature. Okay, correct. Pressure. Hindi ko nabasa yung name, pero nabasa ko yung sagot. Pressure. What else?
Density.
Wait lang, basahin ko yung chat. Okay, number of particles.
Volume.
Okay, volume. So those are the 4 factors that can affect gases. Isa-isahin natin sila. Unahin natin si temperature. So si temperature muna. There are 3 units of temperature that we make use in chemistry. They could either be degree Celsius, degree Fahrenheit, and Kelvin. Ang kadalasan na ginagamit natin ay degree Celsius. So temperature, kapag pupunta kayo ng mall, ginagamitin kayo ng infrared gun, or sa thermometer kapag sinasaksak sa kilikili, or maski sa kung gaano kainit ang place, yung heat index, naka-Celsius siya. Sa Fahrenheit naman, kadalasan itong ginagamit sa US. Tapos, sa Kelvin naman, ito yung ating unit for international unit for temperature, Kelvin. So how do we convert each of these units of gases or units of temperature?
Kasi mama,
So for example, degree Celsius converted to Kelvin, madali lang siya. It is degree Celsius plus 273.15. So kapag meron kang Celsius, tapos i-convert mo siya sa Kelvin, just add 273.15. For example, the normal body temperature is 37 degrees Celsius. How do we convert this to Kelvin? Plus 273.15. So what will be our temperature in Kelvin? This will be equal to 310.15
10.15.
Kelvin. So this is our temperature in Kelvin. Paano naman kapag from Fahrenheit to Kelvin? Degree Fahrenheit to Kelvin. We have no direct computation for this one, or we have no direct formula for this one. We have to convert first degree Fahrenheit to degree Celsius, and then degree Celsius to Kelvin. So for example, we have 212. How do we convert this to Kelvin? Una, degree Fahrenheit to degree Celsius is equal to degree Fahrenheit minus 32, and then divide all of that by 1.8. Sa mga dati yung textbook o sa mga teachers inyo dati, may 5/9 or 9/5, bakit pa natin lilituhin or babalik-balik na rin kung pwede naman natin ilagay na 1.8, di ba? So, 212 degree Fahrenheit minus 32 divided by 1.8.
100 po.
Okay. Isa-isain muna natin, step by step. So, 212 minus 32 is 180 divided by 1.8. So, kung sagot niya, it is 100 degrees Celsius. Next, from Celsius naman to Fahrenheit, hindi na pala nakikita. From Celsius to Fahrenheit naman, anong step? Celsius to Fahrenheit is Celsius plus guys,
Nag-echo po.
Okay. So Celsius plus 273.15. So dito, 100 degrees Celsius plus 273.15, our final temperature will be 373 Kelvin. So this will be equal to 373.15 Kelvin. So yun yung sa temperature. What about sa pressure? Sa pressure, we have 5 units. 180, we have ATM, or atmospheric pressure. We have millimeter per mercury, or mmHg. We also have torr. We have PSI, or pounds per square inch. And then we have kilopascal. Now, meron tayong tinatawag na standard temperature at pressure. The standard temperature is 0 degrees Celsius. The standard pressure naman, noon ang ginagamit ay 1 atm. Pero ngayon, binago na hindi na standard pressure ang 1 atm. Ang standard pressure is 100 kilopascal. Pero based on research, sa mga sinearch ko, noong mga nakarang araw, hindi nila ginagamit na kilopascal ang standard pressure. They still make use of 1 atm. So in accordance to that, we're going to make use of 1 atm as our standard pressure. Now, 1 atmospheric pressure is our standard pressure. It is equal to 760 millimeter mercury. Also, the same with torr, 760, ang isang atm. For PSI, or pounds per square inch, 1 atm is equal to 14.696 pounds per square inch. For kilopascal, it is 101.325. So ito yung conversion ng 1 atmospheric pressure. So let us have an example. So for example, ang given sa inyo ay 355 kilopascal. And then we have to convert this to ATM. Now, using our given 355 kilopascal, next is we are going to get the conversion. So since ang involved dito ay si ATM at kPa, kukunin natin yung values nila. Sino ang ilalagay natin sa denominator? Si
KPA po.
PA. Okay. Our denominator, yung unit niya, ay dapat the same din sa given para ma-cancel. So, 1 ATM, 101.325 kPa, ang lalagay natin sa denominator ay yung kPa. So, 101.325 kPa. At sa taas, yung hinahanap natin, 1 ATM. So, cancel kPa. So, 355, kapag nasa baba, divided by 101.325, times 1, this will be equal to 3.50 ATM. Remember, kapag mole for decimal places, the rest 2 decimal places lang. Okay, so ganun lang mag-convert sa pressure. Number of moles, ito yung ginagawa natin, weight, mole, molecular weight. And then next, we have volume. Sa volume, meron tayong liter. It is the standard international unit for volume, liter. Pwede maging ml, pwede maging kiloliter, or megaliter. There are instances na kung minsan ang ginagamit na unit for volume ay cubic centimeter, cubic meter, cubic kilometer. So kapag may nakita kayong unit na ganito, it is already understood na volume ang hinahanap. Okay? So let's start with number 1. Ang gagawin natin ay sasagutan natin muna yung mga odd numbers. So 135. And then after natin sagutan yung 135, punta tayo sa 246. Okay. Number 1. A 20-liter gas kept in a movable piston has an initial pressure of 1.5 atm at 25 degrees Celsius. If the piston is allowed to expand isothermally or at a constant temperature at 45 liters, what will be the resulting pressure of the gas? So, bago tayo mag-start, ang laging una natin gagawin ay alamin natin kung ano yung mga given. So what are the given in this question in number 1?
Volume.
Okay, volume. So sabi niya, okay, so dalawang volume natin. 20 liters tapos 45 liters. Alin dyan ang initial, alin dyan ang final?
20 liters initial, 45.
Okay. So V1 or initial volume is 20 liters. Ito yung bago pa magkaroon ng changes. V2 naman, yung 45 liters after the change daw. Next, ano pa yung mga given dyan?
Pressure po.
Okay, pressure. Pressure is
1.5.
1.5 atm. Next, yung Celsius. Anong unit yan? Unit ng temperature. So the temperature is 25 degrees Celsius. Next naman, based on the question, ito yung mga given. At ang hinahanap natin ay yung final pressure. Now, sinabi ba na merong changes sa temperature? So, based on the question, sabi niya, constant daw yung temperature. So, negligible yung value ng temperature. We can erase temperature. So, therefore, dito sa question na to, ang may kinalaman lang ay ang volume at pressure. Now, the gas law, which is about the volume and pressure, is called the Boyle's law. Boyle's law is the one, or the gas law, which is concerned with the relationship of volume and pressure. It is mathematically expressed as P1 V1 is equal to P2 V2. Okay? So ito yung formula for Boyle's law. Next, using our given, ano ang nawawala?
Pressure.
P2.
P2.
So, P1 V1 is equal to P2 V2. Nawawala ang P2. So, kailangan nating i-divide yung kasama nung nawawala. So, nawawala si P2. Ang kasama niya si V2. So, we have to divide both sides by V2 para maalis, para ang maiwan lang ay si P2. Cancel V2. So, P2 now is equal to P1 V1 over V2. Okay. Next, tignan natin yung mga given. Ang volume ba magkapareho lang ng unit?
Yes, sir.
Okay, yeah. Kapag magkapareho ng unit, you can proceed. Pero kapag magkaiba ng unit, i-convert mo yung isa. For example, ito ay ml. So, pwedeng yung liter gawin mong ml or yung ml gawin mong liter. Kaya na ano, okay lang. Pareho lang din ang lalabas na sagot. Okay. So, P2 is equal to the value of P1 is
1.5.
okay, 1.5 atm. The value of V1 is
20 liters.
20 liters.
20 liters.
the value of V2 is
45.
45 liters.
So, cancel similar units. So, 1.5 times 20 divided by 45, this will be equal to 0.2 decimal places.
67.
Okay, 0.67
0.67.
atm. So, the final pressure is 0.67 atm. Okay. Now, pansinin natin, nung 1.5 ang pressure, 20 ang kanyang volume. Ngayon naman, nung bumaba ang pressure, ano nangyari sa volume?
Nag-increase.
Nag-increase. Simple.
The relationship of Boyle's law is inverse.
Directly proportional.
Inversely proportional.
Sabihin, kapag bumaba yung isa ay tataas. Inversely proportional. Wait kang sandali.
Repeat po yung
Yung
type of yung law po niya. Hindi ko po masyado nag-echo yung voice niya po.
Okay, sige. So guys, pakimute muna yung mga microphones niyo. Now, kapag sa mga given, ang naiwan lang ay volume tapos pressure, then this is a relationship na ang kinalaman ay Boyle's Law. Kasi sa Boyle's Law, ang kanyang formula ay P1 V1 at P2 V2. Ibig sabihin, pressure and volume lang yung kanyang pakialam or yung kanyang concern. So since volume tapos pressure lang ang nasa mga given, we will make use of the formula ng Boyle's Law. So dito sa Boyle's Law, P1V1, it is equal to P2V2. Now, in order for us to determine the missing, nawawala kasi yung P2, ang ginawa natin ay ganito. So P1V1 is equal to P2V2. Ang nawawala dito ay si P2. Ito si P2. Ngayon naman, kailangan nating ihiwalay si P2 sa equation. So, in order to do that, we have to divide both sides ng kasama nung nawawala. Ang kasama ng nawawala dito ay si V2. So, si V2 ang magiging denominator sa both sides. So, makakancel si V2 dito, may iwan na lang si P2. So, therefore, P2 will now become P1V1 over V2. So, ito na ngayon yung lumabas. Ito yung P1 natin, 1.5 ATM. V1 is 20 liters and V2 is 45 liters. So, lahat ng mga nasa taas i-multiply, tapos i-divide siya ng nasa denominator. Ang lalabas ay 0.67 ATM. Now, we're going to look at this. We're going to take a look at the given. So, nung dati, ang volume niya ay 20 liters at 1.5 ATM. So, nung ang naging pressure niya ay naging 0.67, ang volume niya from 20 naging 45. So that means nag-increase. Bumaba yung pressure, tumaas yung volume. So since bumaba yung isa at yung isa ay tumaas, we can say that the relationship in Boyle's Law is inversely proportional. So inverse ang kanyang relationship. Okay, so to reinforce this, yung number 2 na lang muna sinasagutan natin. Wait lang sandali. Kailangan na uminom ng gamot. Okay, number 2. An air compressor contains 11.5 liters of gas at 1.1 ATM. If the pressure inside the compressor has to be increased to 4.3 ATM without changing the temperature, what should be the final volume? Okay, so what are the given?
Dalawang pressure po.
Okay, yung pressure. The pressure, nung umpisa ay ano ang initial pressure niya?
1.1 ATM.
Okay, 1.1. So in gas law, madali lang actually ang computations. Ang problem lang sa mga computations involving gas law ay yung mga question. You have to identify if the value is initial or final. You have to identify kung ano bang factor na nakaka-affect sa gases, yung value na yon. If it is for pressure, for volume, for temperature. Okay. Next. P1 is 1.10 ATM. What else ang mga given?
Volume.
The volume is
11.5 liters.
11.5 liters. Next, yung 4.3 ATM, ano yan? Initial or final pressure?
Final.
Okay, final pressure. So P2 is 4.3 ATM. At hanapin daw natin ang final volume. Okay, wait lang, sandali. So, nawawala ang final volume. Since this involves pressure and volume ulit, kaya ang formula natin ay kay Boyle's Law. It is P1 V1 is equal to P2 V2. Ang nawawala ngayon ay V2. So, divide both sides ng kasama ng nawawala. Ito yung nawawala. Sino yung kasama niya?
P2.
P2. So, divide both sides by P2. Cancel P2. V2 will be equal to P1 V1 over P2. So, V2 is equal to, the value of P1 is
1.1.
1.1 atm. 1.1 or 1.10 anyway. V1 is
11.5.
11.5 liters. Divided by P2, which is 4.3 atm. Cancel atm. So 1.1 times 11.5 divided by 4.3. So
2.94 liters.
okay, correct. 2.94 liters. So this is 2.94 liters. Nung ang pressure niya ay 1.1, ang volume ay 11.5. Nung tinakpan ng pressure to 4.3, ano nangyari sa volume? Bumaba. So, inversely proportional. Madali lang ang gas law, di ba? So you just have to know how to identify the given. Okay, let's move to number 3. Pakisabi ko masyadong maliit yung sulat ko. Okay. Number 3, 50-liter tank yung gas inside the laboratory, pressure of 5 atm at 25 degrees Celsius. How much will the pressure increase at noontime when the temperature reaches 32 degrees Celsius? What are the given?
50 liters.
Okay, yung 50 liters, ano yun? Initial or final?
Initial.
Okay, P1 is 50 liters. Next, what else?
Pressure.
Okay, yung pressure natin, P1 ay? Okay, 5 atm. For temperature,
5 degrees Celsius.
Okay. Temperature is initial yan kasi sabi niya wala pang nababago. So 25 degrees Celsius. Next, how much will the pressure increase? So P2 ang nawawala. Tapos at noontime when the temperature reaches 32 degrees Celsius. So nabago daw ang temperature. So T2 is equal to 32 degree Celsius. May sinabi ba sa question na nabago ang volume?
Wala po.
Wala. Volume is negligible in this case. So this one, it is the relationship between pressure and temperature. Okay? So this one is under Gay-Lussac's law. Now, Gay-Lussac's law is concerned with the relationship of gases in terms of temperature and pressure. It is mathematically expressed as P1 over T1 is equal to P2 over T2. Okay? Kapag ganyan na, we have to cross-multiply. Sino ang nawawala dito sa ating given, ay sa ating question?
P2.
P2 ang nawawala. So therefore, P2 is equal to, sino yung kasama ni P2? Based on the cross multiplication.
T1.
Okay, si P2 yung nawawala, ang kasama niya ay si T1. Therefore, si T1 ang magiging denominator. Kung sino yung kasama ng nawawala, siya yung magiging denominator. Okay, gets? Next,
Yes, sir.
the numerator yung kumpleto, P1, T2. Masyado bang mali yung sulat ko? Nababasa niyo pa ba?
Nababasa ko.
Mabasa po, sir.
Next, what is our pressure? Initial pressure?
5.
5 atm. What is our final temperature?
32.
32
Okay.
degrees Celsius.
Celsius. Now, in all of the computations in gas laws, dapat lahat ng temperature ay nasa Kelvin. So we have to convert 32 degrees Celsius to Kelvin. So how do we do that? 32 plus?
273.15.
Okay. So 32 plus 273.15 is equal to 305.15 Kelvin. Lahat ng temperature dapat naka-Kelvin. Next, what is our initial temperature?
25 degrees Celsius.
Okay, converted to Kelvin, this will become 25 plus 273.15. This will become 298.15 Kelvin. So cancel Kelvin. So 5 times 305.15 divided by 298.15. What will be our final pressure?
5.12.
Okay, 5.12 atm. So this is 5.12 atm. So nung ang ating pressure ay 25 degrees, ay nung ating pressure ay 5, ang temperature ay 25. Nung tinaasan natin ng temperature, ano nangyari sa pressure?
Tumaas din.
Tumaas din. So therefore, Gay-Lussac's law,
Directly
ang kanyang yes, correct. Ang kanyang relationship ay directly proportional. Kapag tumaas yung isang value, tataas din yung kabila. Kapag bumaba yung isang value, bababa din yung sa kabila. So that is Gay-Lussac's law. So, kagaya na sinabi ko, ang importante ay alam mo kung ano yung mga given. Kung ito ba ay pang pressure, volume, or temperature. Tapos, importante din na alam mo yung importante din na alam mo kung initial siya or final. Let's go to number 4. A confined amount of gas at 10 degrees Celsius has a pressure of 2.5 atm. What is the new pressure if the temperature is increased to 50 degrees Celsius? So what are the given?
10 degrees Celsius.
Temperature 10 degrees Celsius.
Okay, initial temperature ay 10 degrees Celsius. Ano pa?
Pressure.
Okay, initial pressure ay 2.5 atm. Next, what about 50 degrees Celsius? Ano yan?
Final temperature.
Okay, final temperature or T2. Hinahanap natin ang P2. Yun uli ang unknown. So, since temperature at pressure pa rin siya, it is still under Gay-Lussac's law. So, the formula for Gay-Lussac's is P1 over T1 is equal to P2 over T2. Cross multiply uli. Sino ang nawawala? Si
P2.
Okay, P2. So P2, kung sino yung kasama ni P2, automatic ilagay mo na siya agad sa denominator. Ito si P2 nag-cross multiply, si T1 ang kasama niya, so automatic ilagay mo na siya agad sa baba para hindi ka malito. Tapos yung kabila, yung kompleto, sila yung numerator, P1, T2. Next, P2 is equal to, ano ang value ng P1 natin?
2.5.
Okay, 2.5 atm. Ang value ng T2 natin ay 50 degrees Celsius. Celsius uli, convert to Kelvin. So, 273.15 plus 50. This will be 323.15 Kelvin. Next naman, ang ating T1. T1 is 10 degrees Celsius, convert to Kelvin. So, plus 273.15, this will become 283.15 Kelvin. Cancel similar units. So 2.5 times 323.15 divided by 283.15. So this will be
2.85.
okay, 2.85 atm. So 2.85 atm. Nung 10 degrees Celsius, 2.5. Nung 50 degrees Celsius, tumaas ang temperature, tumaas din ang pressure. So directly proportional. Okay? Do you have any questions so far?
Sir, question po.
Yes po.
Sir, kapag po ba may mga problems that involves computation of pressure, dapat po ba standard pressure lang po ang gagamitin na unit?
Okay, kapag doon sa mga problem ay nakalagay is STP, for example, 10 liters of gas exists at STP, so ang gagamitin mo is standard pressure at temperature. So that is the only time that you will make use of the standard temperature or pressure.
Okay po, sir. Thank you
Okay.
po.
The only time that you will make use of STP or 1 atm tapos 0 degrees Celsius is kung yun yung sinabi doon mismo sa question. Okay? So, anong number na tayo? Number 5. Okay, number 5. Consider a 25-liter gas in a container initially at 25 degrees Celsius and 1 atm. If this gas is heated to 80 degrees Celsius, what will happen to its volume under constant pressure? So what are the given? Okay, now there's a catch in identifying kung initial or final siya. Kapag sinabi niyang initially, or kapag sinabi niyang before, or kapag naka-past tense siya, most likely siya yung initial. Kapag naka-future tense siya, for example, will be increased, sinabi niya, naka-future tense, or kapag sinabi niya na the final, or what will happen after, yun yung mga final na value. Okay, so sinabi niya dito initially at 25 degrees Celsius and 1 atm. So, ibig sabihin, sila yung initial temperature and pressure. Okay? So, para sa mga nalilito, that's the catch para mas madaling malaman kung siya ay pang-initial or pang-final. Okay, number 5, what are the given?
$25.0
Okay, so yung 25 liters, that is initial volume. So, 25.0 liters. Tapos, yung ating 25 degrees Celsius ay T1 kasi initially, sabi niya, 25 degrees Celsius. Tapos, initial pressure ay 1 atm. If the gas is heated to 80 degrees Celsius, so ito, nakapang-future tense siya. If the gas is heated to 80 degrees Celsius, so final temperature. So T2 is 80 degrees Celsius. What will happen to its volume? So ibig sabihin yung V2 ang nawawala. Yung P2 is under constant pressure. So these are the given based on the question. At since sinabi niya na constant pa rin ang pressure, alisin na natin yan. So this means that the question involves the relationship between volume and temperature. Now, kapag ang given ay volume tapos temperature lang, this is Charles' law. Charles' law is the law for gases which is concerned with the relationship between volume and temperature. It is mathematically expressed as V1 over T1 is equal to V2 over T2. So, ganun uli. Cross-multiply uli sila. So, ang nawawala ay si V2. Isulat mo na agad si V2. Tapos, kung sino yung kasama ni V2, automatic siya na yung magiging denominator. In this case, ito si V2. Ang kasama niya ay si T1. So, therefore, ang denominator natin ay T1. And the numerator yung the rest, V1, T2. Next. For our initial volume, it is 25 liters. Final temperature, T2 kasi, so final temperature, 80 degrees Celsius, but we have to convert that to Kelvin. So 80 plus 273.15, this is 353.15 Kelvin. Divided by T1. T1 is 25 degrees Celsius, converted to Kelvin, that is 298.15 Kelvin. Cancel Kelvin. So 25 times 353.15 divided by 298.15. The final answer is?
32.32.
Ano po?
32.32.
29.61.
29.61. 29.61 liters. I-double check ko lang. 25 times 353.15 divided by 298.15. Okay, 29.61 liters. So, 29.61 liters. Nung tumaas ang temperature natin from 25 liters siya nun, nung tumaas siya to 80 degrees Celsius, ang nangyari sa volume natin ay tumaas din. So therefore, Charles' law, ang kanyang relationship ay, yes, directly proportional. So far, alin yung mga laws na directly proportional?
Charles' law and
Gay-Lussac's law.
Okay. Okay, correct. Charles' law and Gay-Lussac's law. Ang inverse ay?
Boyle's law.
Okay, Boyle's law. So long as you know the given, malalaman mo na agad kung ano ang formula na dapat gagamitin. Number 6. What are the given in number 6? Okay. Una, yung 250 ml. Ano yan?
volume.
Okay. Initial volume is 250 ml. Next, yung 720 torr, ano yan?
Pressure.
Okay, pressure. Initial pressure is 720 torr. Next, 25 degrees Celsius.
Temperature.
Initial temperature. So, 25 degrees Celsius. Next, sabi niya, if the pressure is held constant and the temperature is raised to 100 degrees Celsius, so T2 ngayon ay
100 Celsius.
100 degree Celsius. Tapos, what will be its new volume? So, ano ang magiging bago? So, since nakapang future siya, so yun yung V2. Nawawala ang volume. Now, based on the question, ito yung mga given. At since sinabi niya na constant daw ang pressure, we can remove the value for pressure. So, therefore, ang given pa rin natin ay volume and temperature. It is still under Charles' law. So, V1 over T1 is equal to V2 over T2. Nawawala ang V2, cross-multiply. So, isulat na si V2. Kung sino yung kasama nung nawawala, siya yung denominator. So, in this case, T1. At gawin natin numerator yung kompleto, yung V1, T2. Okay. Next, V2. V1 is equal to 250 ml. Next, final temperature is 100 degrees Celsius. Convert to Kelvin. This is 373.15 Kelvin. T1 is 25 degrees Celsius plus 273.15 magiging 298.15 Kelvin. Cancel Kelvin. So 250 times 373.15 divided by 298.15, our answer is?
312.
Okay. 312.89 milliliters. So 312.89 ml. So tumaas ang temperature from 25 to 100, ang volume tumaas from 250 to 312.89. So that is the third law of third gas law. First is Boyle's law, second Gay-Lussac's, third Charles' law. Let's go now to our fourth gas law. Mamaya, pagkatapos natin i-discuss itong mga to, we will try to be more creative with the question kasi ganun ako magbigay pagdating sa quizzes and exams. Pero wala tayong exam, so pagdating sa quizzes and seat works. Number 7. Ayun. Okay. So sabi niya, A canister of butane gas, or C4H10, used for portable cooking is available in a store in two sizes, 750 ml and 2 liters. The 750 ml canister contains 85 grams of butane with a pressure of 48 atm at 28 degrees Celsius. How many grams of butane are present in the bigger canister under the same conditions of pressure and temperature? So, ang mga given natin dito ay, una, volume. So yung isa daw ay 750, yung isa ay 2 liters. So we can say that the initial is 750, the final is 2 liters. Kasi magkaibang canister sila, pero we can make use of the relationship na V1 and V2. So V1 is equal to 750 ml. V2 is 2 liters. Next, ano pa yung ibang given? Sabi niya, grams, yes, grams. Sabi niya, sa amount in grams, the initial ay, doon sa 750 grams, ilang grams daw ng butane yun?
85.
85 grams. Doon naman sa kabila, hindi mo alam. So, unknown yung amount in grams nito. Next, sa pressure, T1, 48 atm. So, sa T1,
28 Celsius.
28 degrees Celsius. Pero sabi sa question, under the same conditions of pressure and temperature. So, based on the question, ito yung mga given. Pero sabi niya, wala daw na bago sa pressure and temperature. So, negligible yung mga values ng pressure and temperature. Now, dito, ang naiwan ay volume tapos amount of substance. So, therefore, this is a relationship between volume and the amount of substance. This is Avogadro's law. Avogadro's law is concerned about the relationship between the volume and the amount of substance. And it is mathematically expressed as V1 over N1 is equal to V2 over N2. N is the amount of substance in moles. Kasi di ba ang mole natin, pwedeng ganyan isulat, pwede ring MOL lang kapag shortcut, pwede ring N. So we have to identify the amount of mole of the butane dito sa 750 ml. So, ano ang magiging formula muna natin para ma-identify yung... Yes?
Convert muna yung 85 grams to moles.
Okay, correct. We have to sorry, sumisigi ang aking hyperacidity. Okay, so we have to convert first yung given ng grams to mole. How do we do that? Weight over molecular weight. So, yung sa triangle natin, ito yung mole, ito yung weight, ito yung molecular weight. So, nawawala ang mole, so weight over molecular weight. The weight is 85 grams. The molecular weight of butane, ang butane ay C4H10. So, 4 ang carbon times 12.01, yun yung nasa periodic table. Si hydrogen, 10 ang hydrogen times 1.01. So, 4 times 12.01, this is 48.04. Next, 10 times 1.01, this is 10.1. Ipag-add, so this will become 58.14 grams per mole. So, nakuha na natin ngayon ang molecular weight. So, mole is equal to weight over molecular weight. So, 85 grams divided by 58 grams per mole. This will be equal to 58.14.
1.46.
Mole siya, kaya dapat 4 decimal places.
1.46.
Okay, correct. 1.4620 or 1.462. Okay. Nakuha na natin yung amount in mole ng 750 ml na canister ng C4H10. So using the formula now, cross-multiply ulit kasi ganito ang itsura niya. Kapag merong over na nakalagay, cross-multiply parati. So, ang nawawala dito ay yung amount ng moles ni V2. So, nawawala yung N2. So, isulat N2. Sino yung kasama ni N2?
V1.
Okay, V1. So, automatic si V1 na kasama nung nawawala, magiging denominator. The rest, magiging numerator, V2 and 1. Next, yung volume natin magkaiba ng unit. Kailangan natin gawing magkapareho. So, yung ml, pwede mong gawing liters. Yung liters, pwede mong gawing ml. So, dahil gusto mo, para mas madali, yung liters na lang, gagawin mong ml. So, ita times mo siya sa 1,000. So, 2 liters, how many, so, how many milliliters are there in 2 liters?
2,000.
2,000.
Okay, correct, 2,000. So, the final volume is 2,000 milliliter. The initial amount of substance or mole is 1.4620. Divided by V1 is 750 ml. Cancel ml. So, this will be equal to
126.67 grams.
It is equal to 3.90.
3.90.
Mole siya. Kay, mole yung given, kaya 4 decimal places.
3.9147.
Bakit eh? Iba-iba yung nakukuha ninyo eh.
3.8987.
Okay. So, 2,000 times 1.462 divided by 750. So, 3.898.
7.
3.8987 mole. So, ito ngayon yung amount in mole nung ating 2-liter canister. Yun nga lang kasi ang hinahanap niya ay grams. So, how do we find grams? Nawawala ang grams. So, it is mole times molecular weight. Ito yung mole. So, i-multiply natin yung molecular weight. Ang molecular weight ay 58.14. So, times 58.14 grams per mole. Makakansal yung mole. Ang may iwan lang ay grams. So, this will be equal to
226.67.
okay, correct. So, 226.67 grams. So, therefore, kung doon sa 750 ml ay 85 grams, doon sa 2 liters, it is 226.67 grams. Now, ano ang relationship between the volume and the amount of substance sa Avogadro's law? Nag-increase. Okay. Since nung 750 ml, 85 grams, dito nung 2000 ml, 226. So parehong tumaas kaya tama, directly proportional. Okay. Madali lang, di ba? Next. Another example, number 9. Ay. It is already 5 pala. We only have 30 minutes left. Okay, number 10 na lang. Okay. Wait, anong number na tayo? This is number 7, number 8. Number 9 na tayo. So that is Avogadro's law. So far, isa pa lang ang nagiging inversely proportional. The rest ay directly proportional. Next, number 9. A gas sample held in 1 liter piston at 305 Kelvin has a pressure of 0.75 atm. The piston was heated to 387 Kelvin. At the same time, the volume was expanded to 1.5 liters. Will the pressure decrease or increase? So what are the given? Unahin natin ang pressure, ay ang volume. Initial volume is 1 liter. Yung 305 Kelvin, that is initial temperature. Next, yung 0.75 atm, that is
Pressure.
initial pressure. Next, nagkaroon ng changes. Ininit daw yung piston, kaya ang naging temperature niya ay 387 Kelvin. Tapos, nung ininit siya, yung volume from 1 liter naging 1.5 liter. So, the final volume is 1.5 liter. Ang tanong niya ngayon ay, will the pressure decrease or increase? So, hanapin natin ngayon ang final pressure. Based on the given, ito yung ating, based on the question, ito yung mga given natin. So, pinagsamang volume, temperature, and pressure. So, this is concerned with volume, temperature, and pressure, kaya combined gas law. The formula for combined gas law is P1 V1 over T1 is equal to P2 V2 over T2. Since meron na namang over dito, cross-multiply uli. Okay? Ang nawawala ay si P2. So, sino ang mga kasama ni P2?
V2.
V2 tapos?
T1.
T1.
Okay. Si P2 nandito, ang kasama niya si V2 T1. So, since ito yung nawawala, automatic yung mga kasama niya ay magiging denominator. So, V2 T1. The rest will become numerator. P1, V1, T2. Okay? So, next, P2 is equal to, the value of P1 is 0.75 atm. Next, for V1, it is 1 liter. For T2, it is 387 Kelvin. For V2, it is 1.5 liters. And then for T1, it is 305 Kelvin. Cancel similar units, so cancel liters, cancel Kelvin. Ang may iwan lang ay atm. So, ang gagawin natin ay, we are going to multiply lahat ng nasa numerator, tapos i-divide natin siya sa lahat ng nasa denominator. So, 0.75 times 1 times 387 divided by the product of 1.5 times 305. So, the final...
0.63.
Okay, 0.63 atm. So, 0.63 atm. Bumaba ba ang pressure or tumaas?
Bumaba.
Okay.
Bumaba po.
From 0.75, naging 0.63, kaya bumaba ang ating pressure. So, therefore, the pressure decreased. Hindi natin pwedeng masabi kung directly or inverse ang relationship sa mga gas law ng combined gas law kasi pinagalo-halo na siya. Okay? So, that is combined gas law. Okay, number 11. Let us skip number 10. Ang gagawin ko na lang doon sa mga in-skip natin ay isusulat ko na lang yung answer and then, ayun, compare na lang your answer doon sa answer ko. Let's go to number 11. Number 11, what is the molar mass? Molar mass is the same as atomic molecular weight or molecular mass. What is the molar mass of 1.5 grams of an unknown gas that occupies a volume of 0.68 liters at 0.85 atm and 301 Kelvin? So ano yung mga given dito? May sinabi bang nagkaroon ng changes?
Wala po.
Wala. Okay, walang changes. So that means lahat sila ay initial. So, ano yung mga given? Yung grams of an unknown substance. So, grams is 1.5.
1.5 grams.
Ano ang ating volume?
0.68.
Oh, 0.68. liters. Ang ating pressure ay
0.85.
0.85. The temperature is
301
301
Kelvin.
301
okay,
Kelvin.
301 Kelvin. Now, in this case, using the question at ito yung mga given, walang nabago. So therefore, ang i-assume natin dito, since walang nabago, the gas is existing in an ideal condition. So therefore, this is an example of ideal gas law. Walang sinabing initial or final, kaya ibig sabihin ito ay sa ideal gas law. An ideal gas law, ang kanyang expression or mathematical expression or representation is PV is equal to nRT. So PV is equal to nRT. Ang nawawala dito ay yung ating pressure meron tayo, volume meron, amount in mole, wala. Grams lang ang given. Yung R, it is constant. R is equal to 0.08205 liters ATM over mole Kelvin. And then we have temperature. Since given lahat except yung N ang hanapin natin ngayon. Okay? Bago tayo mag-start, tingnan muna natin yung unit natin. Dito kasi sa liters, dito kasi sa R, liters ATM mole Kelvin. So ibig sabihin, kapag meron tayong given at hindi ito yung units nila, ang mag-adjust ay yung mga ibang given. Si R kasi hindi mo siya pwedeng baguhin. Constant kasi siya. So for example, sa pressure natin, kailangan natin siyang i-convert into ATM. Kung hindi man siya naka-ATM. Ang volume niya dapat naka-liters. Ang kanyang temperature ay dapat naka-Kelvin. Ang kanyang amount of substance dapat naka-mole. So dito, given lahat exact yung N, so we are going to compute for N. So PV is equal to nRT. Nawawala si N, so divide both sides. Kung sino yung kasama nung nawawala, ito yung nawawala si N. Sino yung mga kasama niya?
RT.
Okay, so divide both sides by RT. Makakancel yung R, makakancel yung T. So N is equal to PV over RT. Okay? Next, paano kapag ang kunwari ang nawawala ay yung pressure? So PV is equal to nRT. Ang nawawala ay yung pressure, kunwari. So divide both sides by
V.
V, volume. Kasi siya yung nawawala, dapat maalis din yung mga kasama niya, so divide both sides by V. So therefore, pressure is equal to nRT over V. Paano pag si temperature ang nawawala? PV is equal to nRT. Nawawala si temperature.
Divide both sides by NR.
Okay, so divide both sides kung sino yung kasama nung nawawala, which is NR. So cancel N, cancel R. So temperature is equal to PV over NR. So ganun lang mag-convert sa ideal gas law. Kung sino yung kasama nung nawawala, magiging denominator siya ng left at right side. Okay? So balikan natin yung sa N. So N is equal to PV over RT. N is equal to, the pressure is 0.85 ATM. Volume is 0.68 liters. Our R is 0.08205 liters ATM over mole Kelvin. Tapos ang ating temperature ay 301 Kelvin. So cancel ATM, cancel liters, cancel Kelvin. Ang may iwan lang dyan ay mole. So this will be equal to
0.0234.
okay, correct. 0.0234 mole. Pero ang hinahanap sa question ay what is the molar mass? So can we find the molar mass na meron tayong given na grams at mole?
No.
Actually, isulat natin yung triangle. Okay. Ang nawawala ay molecular weight. Ito. So, the formula could be weight over mole. So, ang weight natin ay nandito given. Tapos, yung mole natin, na-compute na natin yung mole. So, we can actually compute for this one. So, it is equal to 1.5 grams divided by 0.0234 mole. So the final answer will be
64.09.
okay, 64.09 grams per mole. So this is our answer. So yun lang po ang ideal gas law. Now let's try to be a bit creative sa ating mga question. Now, sa gas law kasi, maliban sa alam mo dapat kung ano ang initial at final, alam mo kung para saan yung mga value, if it is for temperature, pressure, or volume, you also have to identify and analyze the question. So for example, meron kang isang lalaki dito. Oh, galing ko mag-drawing. Nandito siya sa tabing dagat. Ang volume ng hininga niya ay 6 liters. So the initial volume ng kanyang breath sa kanyang lungs ay 6 liters. At siya ay ang pressure kung nasaan siya nakatayo ay 1 atm. Ngayon naman, kailangan niya mag-dive. Kailangan niya mag-dive ng 35 meters underwater. And for every 10 meters below the water, tumataas ang pressure ng 1 atm. So ano magiging volume niya kapag nakalating na siya 35 meters below the waters? So initial volume is 6 liters. Initial pressure is 1 atm. Ano ang ating magiging final volume? Yun yung unknown, di ba? So this involves volume and pressure. Nawawala ang V2, pero given ang P2. Ano ang P2 natin ngayon? So for every 10 meters na sumisisid siya underwater, tumataas ang pressure ng 1 atm. So ano ang magiging pressure niya pag nabot niya na itong 35 meters underwater?
3.5.
3.5.
3.5? Are you sure?
350.
Hindi po. Okay, so nagsabing 3.5. So nagsabing 4.5. Wala, biglang nahiya.
Sir, ako 4.5.
Okay. 4.5. Paano naging 4.5?
Sir, kasi meron po tayong initial pressure na 1 atm, then every 10 madadagdagan po ng bali yung 3.5 po na sinasabi nila is yun yung additional pressure po.
Okay, correct. So yun, ganun yung mga question na binibigay ko. Masaya, di ba? So, for example, ito 10 meters, 20, 30, and then 5 meters. So ito yung 10 meters, 20 meters, 30 meters, 35 meters. Dito, sa first 10, dumagdag ng 1 atm. Dito, sa second 10, dumagdag ng another 1 atm. Sa pangatlo, another 1 atm. Sa last one, 0.5 atm. So all in all, kapag nasa tubig na siya, 3.5 atm ang pressure. Yun nga lang, ang initial pressure niya, kailangan nating isama. Kasi sabi niya, before pa siya mag-dive, 1 atm na agad yung pressure. So we have to include 1 atm doon sa initial pressure, doon sa ating final pressure. So therefore, mula dito sa 3.5 na atm underwater, isasama natin yung isa nung before pa siya sumisid sa water. So therefore, P2 is 4.5 atm. Okay? So, ganun yung mga questions na kadalasang binibigay ko. Okay, so, pressure and volume, ano ang gas law na ito?
Boyle's law.
Boyle's law.
Okay, Boyle's law. So, since this is Boyle's law, the formula will be P1 V1 is equal to P2 V2. Ang nawawala ay si V2. So, ito yung nawawala. So, divide both sides by
P2.
P2. So, cancel P2. So, V2 now will be equal to P1 V1 over P2. So, P1 is 1 ATM. V1 is 6 liters. The final pressure is 4.5 ATM. Cancel ATM. So, 6 divided by 4.5, this will be equal to
1.33.
1.33 a liters. So, ibig sabihin, kapag nakapag-dive na siya, ang magiging volume na lang ng hangin sa lungs niya ay 1.33 liters. Okay? So, those are some example. That is one example ng mga question na pwede kong ibigay. So, you have to really understand the question. Maliban dyan sa pagbaba or pagsisid, kung minsan yung iba, gumagamit sila ng hot air balloon at habang tumataas sila, habang lumalayo sila sa center ng Earth, lalong bumababa yung pressure. So you have to include that doon sa inyong analysis kung ilan ang maging initial pressure, initial volume, or initial temperature. Okay? Now, supposedly we are going to discuss Module 17 and 18, but because of the time constraint that we are experiencing, baka ang gawin ko na lang ay i-post ko na lang as video. Gagawin ko na lang siya ng video lesson. It is already 5:20, 10 minutes before the time. We're not going to make use most of your data kasi yung iba sa inyo ay hindi pa naloloadan. So, we're going to end our discussion now.